Hey guys, it's Mrs. Reba. Today we're looking at lesson 6.9, graphing linear inequalities. So far this chapter we've done a lot with linear equations, where we had our x and y variables, which became our x and y coordinates, and we could graph all the possible pairs in a beautiful straight line. In this chapter, we're actually going to talk, or excuse me, in this section, we're going to talk about linear inequalities, and we're also going to continue to relate to real-world scenarios, graphs, and equations. So diving right in, this is a very important review, a very important warm-up. Please take a moment to complete the warm-up. Anything that comes up as a misunderstanding to you is very important to me as well, so please make sure to make a notation somewhere so that we can discuss it in class on Wednesday. So, graphing inequalities on a number line. This would be one variable only. So we will remember that we drew a circle around the boundary point. We shaded the circle if it was included the or equal to symbol. We left the circle open if there was no or equal to. And then we used a test point to determine which side to shade. Yikes. So here we're going to graph m is greater than or equal to 2 on the number line below. Here, of course, our boundary point is the 2 being compared with the m. It is, in fact, a closed circle because the inequality does include the or equal to. Test a point. Let's test negative 12. Negative 12 is greater than or equal to 2? No, this is false, so we would actually shade then the other side. And that's what we're taking a look at. So again, if this review kind of does not click with you, please make a note to make sure that we discuss in class when I see you on Wednesday. This is extremely important for what you'll be seeing in just a matter of moments. We use the same ideas essentially to graph linear inequalities. Some of the same basic ideas. So now as we take a look, we will discuss graphing inequalities in the coordinate plane. The coordinate plane, as we know, includes two variables, the x and y variable. So taking a look, the steps are really similar. We'll first start by drawing a boundary line. I'm using an equal to rather than the inequality symbol. The boundary line is a solid or inclusive line if the or equal to is included. It is a dashed line, kind of like an open circle, a non-inclusive, if there is no or equal to included. So taking a look here, we would then test a point, just like we did before. Test a point to determine which side to shade. So our example, we are going to graph x is greater than or equal to negative 2 on the coordinate plane. So here we have a coordinate plane. Remember, we do have both of our x and our y variable. Our first step is, of course, to draw the boundary line using an equals. So our boundary line here would be x equals negative 2. So here we can see the vertical line representing x equals negative 2. This actually came up on a quiz that we took recently, a vertical line of x equals negative 2. This is a solid line because the or equal to has been included. So if we go ahead and take a look here, we're going to do a test point. The test point, we'll go ahead and test the origin, 0, 0. We would use the x coordinate here, the 0, in place of x. Is it true that 0 is less than or equal to 2? Yes, it is true, which means that the origin should be included in the shaded half. And here we have a graph. Obviously, the shading is really easy to do on the computer. In class, we'll talk a little bit more. When you shade it, you can just shade it nice and lightly with your pencil, just making some nice lines here to show the shading nice and lightly with your pencil. Let's try another example. Here is a graph. We need to write an inequality that describes the set of points in the shaded region. We can see here that the region is determined by a horizontal line. The equation then for this horizontal line is y equals whatever it equals. In this case, whoops, it looks like it says negative 2 here. Let's go ahead and fix that because we can all see that y is not equal to a negative 2. As we can see that y is actually, in fact, in this line equal to a negative 1. The y's that included are all, of course, larger than negative 1, like a y of 0, a y of 1, a y of 2, a y of 3. So the dashed line would also indicate then that it is not including the or equal to. So here our y's are greater than negative 1. So we've seen an example with a vertical and a horizontal line. Let's use one of those diagonal lines. We actually have a term for that. We would call So our next example will include one of these oblique lines that we're taking a look at. We are asked to graph the inequality y is greater than negative 3x plus 3. So as we go ahead and get ready to draw our boundary line, we can see that the boundary line actually will be a dashed line, a non-inclusive, based on this greater than symbol. When we get ready to draw the boundary line, the slope-intercept form actually makes the graph pretty easy to complete. If we take a look, we know based on this plus 3 that the y-intercept is a 3, and based on this negative 3x, that would mean that it goes down 3 over 1. So the line itself is fairly easy to draw given that we do have a slope-intercept form. Our job now is we must determine where we should be shading, because we could be shading to the left or below, I guess, the line, or to the right or above the line. Taking a look, we'll just go ahead and do a test point. Let's test the origin, 0, 0. We will substitute a 0 for y and a 0 for x and make some calculations here, showing that 0 is greater than 3, which we actually know is false. So this time we would not want to include the origin because it makes it false, so we will actually shade the other side. Again, the shading here, obviously it's easy to do with a computer, but you can go ahead and do your shading just by taking your pencil and lightly filling in the graph on the correct side. Let's go ahead and take a look at another oblique line. This one you might want to press pause a little bit more, try a little bit more on your own. We are being asked to draw the graph of negative 3x plus 5y is less than or equal to negative 15. As we take a look at this particular example, we're going to get ready to draw our boundary line. We will substitute in an equals here and find a couple points that work out for us. This is pretty close to standard form, so using the x and y intercept would probably make the most sense. In this case, by looking at the less than or equal to symbol that has been used, we should be able to determine if this line is inclusive, solid, or dashed non-inclusive. And in this case, you are correct. This would be a solid line. So we're kind of standard formish, so the intercepts make it pretty easy to graph. For example, if x is 0, we know that 5y equals negative 15, so therefore our y must be negative 3. And if y is 0, we know that negative 3x is equal to negative 15, therefore x must be 5. So we've got our 2 points. We've got our point 0, negative 3, and we've got another point at 5, 0. We can use those 2 points to go ahead and do the line. And again, this is a solid line simply because as we take a look, it does include the or equal to symbol. So going from here, we need to decide, are we shading kind of the above portion of the graph or the below portion of the graph? So we'll pick a test point. The easiest test point in most cases is the origin 0, 0. So if we substitute in zeros for both x and y, we come up with 0 is less than or equal to negative 15, which again is false, so we'll go ahead and shade the side without the origin. Before coming to class, attempt to write the inequality that goes with this scenario. We will then confirm your inequality and practice graphing in class when I see you. Have a wonderful day. We'll see you Wednesday.